So, wanted to take a few minutes and demonstrate how to launch jobs inside of CloudyCluster. So we've got a standard CloudyCluster installation here with OrangeFS as the parallel file system, and as you can see, everything is up and running. We're going to use Slurm as the scheduler. We have EFS, but we'll be launching the jobs off of OrangeFS for this demonstration. And if we go to the console, you can see here's all the instances that are running. Here's VNC with the visual HPC configuration, so we can just go through and launch some of these jobs and see how it works. We'll be highlighting CCQ, which is the meta scheduler that front-ends Slurm in this case. So we'll be launching jobs through CCQ, and it'll be spinning up the instances as needed for the job. So we'll start with this first MPI prime job, and my nomenclature here is 2, and that matches up with the number of nodes and the number of tasks per node, kind of in that order, just to make it simple. So we'll first take a look at CCQ stat, and we'll see, hey, there's no jobs in the queue, so we'll do a CCQ sub. And since I just tested this, it's not prompting for authentication, but the first time you log in, it'll actually prompt you for the user and password of one of the users that are configured inside of CloudyCluster. But we'll do JavaScript, and let's do MPI prime, and we'll do -2-2, and we'll go ahead and let that launch. And you can see it's given it a job ID. We can see a CCQ stat, and now we can see that the information in there, it lists the scheduler, the job name, job ID, and then the state. And as you can see, if we come over and look at this job, we've uncommented sbatch, since that's the commands that Slurm will look at. CCQ also looks at that and determines, hey, this needs 2 nodes and 2 tasks per node. It will calculate and determine the best instances, and then it will actually spin those up. It takes a few minutes to spin up the instances. And as we can see, we'll go up and do a CCQ stat, and it says creating CG, which is compute group. So if we go look at the EC2 management console again, and now you can see that 2 instances are pending, and they're T2 mediums, and that was determined the best optimization based on the job that was submitted. And it'll take a little while for those to spin up, and then once they've spun up, it will actually release the job to them. Now, while those are spinning up, let's go down and launch another job. So we've got this 4-1 sitting here, and as we can see, this has 4 nodes. We're only going to need 1 task per node on this one, and so we'll do a CCQ sub, change it out to a 4-1, launch that job. It's given it a job ID, and it's pending, and it's in the CCQ, and then it'll be spun up in just a minute. And you see it's creating the compute group state. A minute or so, we'll see the nodes start to spin up for that as well. Now we can see we have 4 T2 micros being spun up for the second job that we did, and the other 2 are still initializing. And just to show how we can do spot pricing now, we'll see in this job script we have comments put in there as $CC-US for use spot, because yes, and spot price is 15 cents, and then a C4 2XL. So if we go look at the instance type console, we'll see the 2XL has 8 virtual CPUs, and if we go back, we can update the tasks to 8, and then we'll save that. And if we wanted to figure out the spot price, we can do pricing history, and we want a C4 2XL, and we can see, oh, it's generally been 12 cents, but we'll go ahead and just put it in at 15 cents to make sure this will launch. Now remember, when you use spot instances, they may be preempted if other people need those. It's really using the excess capacity. That's why it's so much cheaper. So your job should be able to be interruptible if you're using those. or you're willing to run it a couple times, because it generally is a lot less than half the price of an on-demand instance. So we'll go ahead and now submit this job. Well, let's do a CCQ stat. We'll still see they're saying create compute group, and so we'll do this as the MPI prime 2-8 spot, and then we'll launch that one. And if you notice, the instance type is currently available. On the spot ones, they actually check. If you put the instance type, it double checks and makes sure that is available in that region. And then it successfully submits the job. We'll do a QStat. It'll probably say pending. It'll switch to creating compute group in just a second. So we have 3 jobs underway. Now we have the T2 micros that are running. These 2 C42XLs are previously when I was testing. And then here's the mediums that are up and running. Let's go see. We can see they show up in the console, and also the 4 other nodes have made it up in the console. You can see there's the job name of the first job that's submitted that creates those instances, so you know what's going on. And let's go back and see where the stats are. There's still some work that has to be done after you've launched those jobs and the instances are up and running and checked, because then it has to do all the provisioning of the users and the rest of the environment for the HPC mounting, all the mount points for EFS and OrangeFS in this case. So now we can see that the first job is provisioning, and that means it's actually doing the rest of the work to get everything ready to release the job. Now we can see the job is running. That means it's been released to Slurm to actually do the processing. And these are pretty quick jobs, so it'll just take a second to run. And you can see the first job is completed. Now the second job is actually provisioning on the different instance types. And while those are doing their thing, we have one more, which is actually a dam break simulation from OpenFOAM. And we'll see this is also a 2.2. And we'll go change directories to the OpenFOAM directory. And we'll see the dambreak.sh file here. And we'll do a CCQ sub -js, and that one is now submitted. Do a CCQ stat. And we can see the second job is completed now. The spot one is still creating. If we actually go and look at the management console, do a little refresh, and we should now see additional HPC nodes. And now we got the 2 C42XLs. Those are spot. And refresh this page, you'll see there's 2 active requests that are open for those in the spot console. And inside of CloudyCluster, you see now there's all 3 of these compute groups with different instance types. And we can go back to the VNC session. If you notice, that dam break simulation is provisioning very quickly because it's using those same instances as that first MPI prime job. So it'll reuse the instances if they're available. And when the end of the billing cycle comes up, it'll actually check to see if there's anything in the queue for that instance type. If not, it'll actually terminate those instances. Now we'll go ahead and let these finish up. The third one's completed, and now the fourth one is submitted. Do a CCQ stat again. That final dam break job is running. But we go back to the console, all the instances will still be up there. Now, if we decided we made a mistake or something wasn't running right, we could actually issue the cc delete command. And notice we deleted the job, it issued the delete command to the scheduler, and that should all be terminated now. But that gives you an overview and an idea of how to launch all the jobs through CCQ and CloudyCluster.